This lesson will be on perpendicular and parallel lines. Now, if we have two lines with gradients m1 and m2, those two lines are parallel if both of them have the same gradient. So in other words, if m1 equals m2, the lines are parallel if they both have the same gradient. Now, if they're perpendicular, their gradients will satisfy the rule m1, so the gradient of the first line, multiplied by the gradient of the second line equals -1. Or, in other words, if we were to rearrange this, making m2 the subject, m2 equals -1 over m1. So those are the two principles for parallel and perpendicular lines. Let's work through a couple of examples. If we have two lines, let's make them y equals a half x plus 2. That's the first one. And the second one, 2y minus x equals 5. And we want to decide whether these two lines are parallel, whether they're perpendicular, or whether they're neither parallel or perpendicular. Are these lines parallel? I'll just abbreviate perpendicular to perp, or neither. So what we're going to do is we'll look at this first line to begin with. Whenever we're dealing with questions that are asking if lines are parallel or perpendicular, what we're concerned with is the gradient, as we can see from both of these rules here. So the gradient of the first line we'll call m1. m1 equals a half. This line here is already in gradient intercept form, so we know straight away that the m value is a half. Now we need to find the gradient of this second line here. So what we want to do is rearrange it into gradient intercept form. So we've got 2y minus x equals 5. If we rearrange that, add x to both sides, 2y equals x plus 5. Divide both sides by 2 equals x over 2, or in other words, a half x, plus 5 over 2. So our gradient of this line is also a half. Now, because both these gradients are a half, m2 equals a half, therefore we know that they're parallel. Since they've got the same gradient, we know they're parallel. m1 equals m2, therefore parallel. Let's have a go at one more question. Find the equation of the line that is perpendicular, again I'll abbreviate that to perp, to y equals 3 over 4x minus 1, and passes through 3 minus 2. So this one's a little bit different to the previous question. I've given you one line and I want you to find the equation of the line that's perpendicular to it, given that it passes through this set of coordinates right here. So we'll first write out the gradient intercept rule, y equals mx plus c. If we've got a gradient of, let's call m1, the gradient of m1 we know is 3 over 4. Coming back to our rule, we know for two lines to be perpendicular, m1 times m2 needs to equal -1, or in other words, if we rearrange that, m2, so the gradient of the second line is equal to -1 over m1. So we know m2 needs to equal -1 over m1, which equals -1 over 3 over 4, which will give us -4 over 3. So straight away we've got our gradient of the second line, -4 over 3. And if we substitute this back into our gradient intercept form for a line here, we know y equals -4 over 3x plus c. So all I've done is, so far, found the gradient of the second line, substituted it back into y equals mx plus c, and now we need to use this coordinate here to determine the c value. So we know when x equals 3, y equals -2. So let's substitute those in. -2 equals -4 times 3 over 3 plus c. We can cancel those and bring this 4 over to the other side. So add 4 to both sides. -2 plus 4 will give us 2 equals c. And then we can substitute that c equals 2 back into the rule. So y equals -4 over 3x plus 2. So all I've done there is substitute this c equals 2 back into the rule we had with the second gradient. And now this is the equation of the line that is perpendicular to this line here and passing through the point 3, -2. So hopefully that's been a helpful introduction to parallel and perpendicular lines.